Good? Am I on? All right. All right, well, welcome everyone. Thanks for showing up for the 5 o'clock session with me. My name is Paul Gilday. I'm a program manager on the Win.js team, and I'm here to talk to you today about creating fast and fluid user interfaces with HTML and JavaScript and Win.js. And so just a little bit about myself. I've been with the company almost 5 years now. In high school, I worked on client-side Flash development with ActionScript, and then in college, I moved over on the server side and worked with ASP.NET. And so now, now working at Microsoft, I've kind of round-tripped, and now I'm back on the client side talking to you today about HTML and JavaScript. And just to get some numbers, how many of you saw Paul Gusmarino's talk yesterday about what's new with Win.js 2.0? All right, quite a few of you. That's good. So in this talk, I'm going to be talking a little bit more in depth in some of the areas that he touched on in the infrastructure section. And so I got a lot of stuff to go over, so let's just dive right in. And so my goal today is to help us understand as application developers what are the opportunities that we have in our applications to improve performance. And today we're going to discover the APIs that we have available to you that are new in Win.js 2.0 to really help optimize those areas. And we're going to learn how to use these new APIs through some code examples, and a lot of these examples you can get through our SDK sample, so you'll see a lot of that. And so when we started to think about the investments that we were going to do in performance in Win.js 2.0, we worked with the Mail team and the Bing team and the music team to really understand what some of their pain points were. And we actually solicited feedback from third-party applications as well so that we could get that feedback, we could boil it down, and we've boiled it down to kind of these 4 areas of performance opportunities. And we've built some solutions that we can give to you to help kind of improve those areas. And so as I walk through each of these areas, I'm going to talk about some of the problems that we face today as application developers. I'll talk about some of the solutions that we have to help us improve performance in those areas. Sorry. And then I'm also going to kind of ramp up a little bit in complexity. We'll talk about some kind of targeted scenarios, and we'll get a little bit more complex with panning and startup. And so let's start off with UI responsiveness. And this is really about coordinating work. And so when you think about an application today in HTML and JavaScript, most of your application work is on the UI thread. Now, we do have some things that can get work off of the UI thread. We have workers, we have background tasks. We have done a lot of work in the HTML platform to make sure touch input and direct manipulation and panning is done on a separate render thread. But by and large, the app developed that we're running is on the UI thread. And if we execute really expensive code paths, we run into situations where our UI can really become unresponsive, and end users won't feel like that your app is alive and fast and fluid. And so with that, we try to mitigate some of those things. And we have some mitigations today. We can use set timeout or set immediate or request animation frame to kind of schedule future work. But one of the issues that we have with that is that we can't really coordinate and prioritize that work. Because you're going to be saying, oh, I'm going to set immediate and do this stuff later. Win.js is doing that at the same time. But then you make some calls to WinRT, and so you really can't coordinate and prioritize across the entire platform. And that makes it really difficult to make sure that your application is in tune with the rest of the system for UI responsiveness. And so I'm going to talk about the Win.js scheduler. So this was debuted in Paul Gusmarino's talk, and so we'll go a little bit deeper, and we'll see kind of how it's applied across this stack. And so this lives in the utilities namespace. And so the beauty of the scheduler is that it gives you a way as app developers to coordinate your work with the rest of the platform. And so one example is that Win.js, we've moved all of our controls to schedule their work with the scheduler. And so by you scheduling your work, you're automatically in tune with Win.js, and so you can prioritize and coordinate with us. But the really cool part about the scheduler is it's actually built on top of WinRT. And so when you schedule WinRT calls, say you're building an RSS app, and you want to use the syndication API, you can, when you schedule the work with WinRT, it'll come back at that same priority that you've scheduled with the WinJS scheduler. So it's really cool that you can actually really kind of line up all of that work across the entire platform. And we believe that that the scheduler is probably going to hit a lot of your scenarios, and we highly recommend using it. That'll be the one spot for you to really make sure that your work's coordinated. But we built it in a kind of general purpose way so that if you wanted to layer on your own app-specific behavior or policy, you could do so. And so an example of that is, say you're very particular about loading content that's visible on the screen and not loading content that's not. And then as the end user pans across, you're going to dynamically loading content. And so you can build all of that tracking logic on top of the scheduler and not build a separate scheduler because you won't be in tune with the rest of us. So we make it really easy to do that. And so we think it's a really powerful tool, and we're recommending everyone to use it. And so I mentioned that you can not only kind of coordinate across layers in the platform, but you can also kind of prioritize work inside those layers and across those layers. And so let's talk about the priorities that we have in the scheduler. And so we have kind of three big buckets. We have a high, a normal, and we have a low. And so I'm going to talk about each of these areas and when it's some examples of when to use it and how we think application authors are going to use it. And so let's think about that RSS reader app that we're building. And so we have this big high priority bucket. And so our recommendation is to use this sparingly and appropriately. And so what we mean by that is that this priority can actually block layout from happening in the HTML platform. And so if you run a ton of high priority tasks, you're going to be blocking layout, and your app is actually going to be less responsive than you wanted it to be. And so there are some appropriate times where you have to be really diligent about saying, oh, well, I really need this piece of code to execute, and I need to happen before anything else to happen after that. And so I need this to really happen, and so you have to be really careful of how you use it. And so say like in an RSS reader, you need to have content inside of your UI. And so maybe it's a really high priority for you to process that XML and build an object model so that you can actually load it into your UI. And so that's a good example. Now, let's talk about the normal bucket. And so you can see this one has the biggest range of priorities for you to use. And we believe that most of the application work that you'll do today is going to fit within this range. And an example of that could be, so say you have your canonical RSS reader, you have the feed pane on one side and the reading pane on the other side, and you really want to prioritize the work that's going on inside of the reading pane and not in the feed pane, because that's where an end user is going to look when you click the feed in your feed pane, and you're going to say, oh, great, yeah. And so you want to be able to have that finite control over the execution of work for all parts of your UI. And so we have that really big range for you to do so. And then finally, we have kind of the low bucket, which is for those tasks that only really need to be executed when the application is idle. And so an example of that could be, well, you don't want to hit your network to go look and check for new feeds when the end user is interacting with your application. And so maybe when the app is kind of idle, you can do that network request, and you can check to see if you actually need to go do a full network request to pull in more data. And so that's a good example of when you can do that. So let's look at a kind of a trivial code example here. And so if you're familiar with set immediate, set timeout, this is going to be really easy for you. And so essentially with the scheduler, it's just a function and a priority associated with it. And so in this first example here, this is just scheduling some future work to execute at normal priority. But in the second example that I have here, we have some optional parameters that you can pass. And so one of the nice things is you can pass the this context, so you don't have to do that that trick, which can sometimes lead to unmanageable code. I know I've said, oh, well, this doesn't exist. Oh, right, yeah, that. Awesome. And also, and this is often overlooked, but we give you just a description so that you can console log all of your jobs, so that you can actually ensure that all of your jobs are executed at the right priority in the right order. And so that's really super helpful. And we have an SDK sample. I'm not going to go into it today, but it goes over the more advanced features that we have in the scheduler, like how to cancel jobs, pause jobs. We can do yielding, and I'm going to cover one of those features later on in the presentation. And so the key takeaway that I have for you to ensure that you have really good responsive UI is leverage our scheduler, because that's going to make sure that you're coordinating your work with the rest of the platform. And we think that that's a really good thing for applications. And so we're going to move on to the next section here. And this is all about kind of maintaining the control lifetime of your UI. And so if you went to the talk yesterday about what's new in WinJS 2.0, we're going to talk about the problems that we faced associated with that. And so looking in WinJS 1.0, we had kind of a lack of a clear pattern for you, app authors, and control authors to participate in a consistent control cleanup. And what ultimately happened is that applications had to build in some of those constructs themselves and manage those. And so that's really difficult. We did have some dispose capabilities inside of WinJS, but it wasn't really clear and consistent across the entire framework, or the entire library. And so that seemed to be kind of an unmanageable thing. And also, the single-page application architectural pattern or model is kind of amplifying the need to ensure that you're actually cleaning up your UI. So instead of doing like a full page refresh where you get a whole new context, the problem is that we're actually loading in large trees of UI elements and removing large trees of UI elements. And if we're not diligent about severing connections and references between those UI elements, we can lead to memory leaks. And so sometimes that can be really hard to manage. And so in the 2.0 talk, we talked about the new dispose pattern. And so I'm going to go a little bit more in depth on what that is. And this pattern is similar to other patterns that you've seen, like in jQuery UI or YUI using destroy. And so this pattern is actually just built right into WinJS. And all of our UI controls leverage this pattern. So after you learn this pattern today, you can use it right on our controls, and then you'll be able to implement it in your own custom controls. And so we'll kind of go over that. And so that's the beauty about this pattern, is that it's a two-sided pattern, in that you can implement it in your controls, and you can call controls that implement the pattern. So it's really nice. And so we've just kind of talked about that just in kind of the single kind of control instance. And where this becomes really important is where you have these large nested UI trees of UI elements. And so you want to be able to call dispose on those to ensure that this large tree of UI gets cleaned up appropriately. And so we can see some of that in the navigation and panning scenarios. And so we'll talk a little bit about that. So let's jump into some code. And so we're going to talk about first how to implement this on the control side, and then we'll move over to the app side. And so here we're just implementing a control here. And the two things that you need to do as a control author is, first, you need to mark your top level, your root element as WinDisposable, and we'll see why that's important later. And then implement a dispose function, and that's it. And so let's dig into that dispose function and see what we're responsible for in here. And so at the very beginning here, we just do like a global check here to make sure that we're more resilient against multiple calls to dispose if we've already been disposed. And then as a control yourself, you're responsible for kind of cleaning up any event handlers that you have, or any key hooks that you may have initiated, any resources, close down streams, and sever connections, and all that great stuff. And that's what dispose's core responsibility is for that control. However, if you're a control that hosts other UI controls, you're also responsible for cleaning up those child elements. And so we make that really easy in WinJS with this helper function dispose subtree. So if those controls participate in our dispose model, what that will do is it'll crawl that tree, it'll look for the WinDisposable class, and then it'll call dispose on those controls. And so as long as everyone's participating in this pattern, this becomes really easy to maintain the control lifetime for really large UI trees. And so as you can imagine, this is the same technique that you would use if you were building a very simplistic navigation function where you simply just clean up the entire subtree, remove that subtree, and then insert another subtree. And if you go to the VS templates, if you look in the navigator.js, the page control, the page navigator control actually implements both sides of this pattern. So you can see where they actually call the dispose subtree inside of their navigating function. And then you can also see the dispose method where they take away some of those key hooks. So my call out for you is use the dispose pattern, because that's going to give you the best management of lifetime of your UI controls. And so we think just with these two improvements that you're going to be able to have more utility to do really amazing things in your applications to ensure UI responsiveness and kind of manage your memory. And so I'm going to shift gears now, and we're going to go into a little bit more of a more intermediate scenario. And we're going to talk about panning. And so I'm going to kind of frame this and set up what panning is, and then I'm going to talk about what the relationship that we have, both as you, the app developer, and from our perspective in Win.js, into this whole scenario so that we can deliver a great end-user experience in your application. So here I just have a very simplistic diagram, and we're just going to kind of explain what panning is. And so we have some viewport where the end user can see some content on the screen, and that's represented by this little orange box here. And inside of that viewport, we have a large surface of items, and those items are represented by these blue boxes here. And so as the end user starts panning this large surface in this viewport, we're presenting more and more content to the end user. And as they pan the other way, we're going to present that content that they've already seen. And so that's kind of just the big, broad overview of how panning happens in the system. And so now I'm going to talk about this relationship that we have that we need to ensure that we deliver to provide a really great user experience for our users. And so the biggest thing that you should be responsible as an app developer is that it's your job in this relationship to render items. And so you want to ensure that you can render items as fast as possible. And we have some tools in Win.js that helps you do that. And so we'll go over what some of those tools are and some of the improvements that we have with that. And so to talk about the other side of that relationship, what we need to do from the Win.js perspective, and to be very specific, from the list view controls perspective, because that's kind of the way that we manifest panning, is that we're responsible for telling you when you should render your items. And so most importantly, when there's items inside of the viewport, we're going to tell you, hey, you got to render. And so you're going to start rendering. But we're also responsible for kind of managing a front buffer and a back buffer of items. And so we'll be telling you to render in those cases as well. And so it's our job to really maintain all of the items within that large surface. And your job is to really figure out when I just need to render those items as quickly as possible. And so let's talk about the challenges that we face as app developers and some of the challenges that we've faced in the list view control, and then talk about some of those solutions. So, like I said before, we have some tools for you today in Win.js 1.0 that lets you do item rendering. And so some of those are, we have binding templates, we have rendering functions, and you guys can actually use other templating libraries like Mustache or JS templates. I think that they're called that now. And there was an inherent trade-off between some of those technologies. And item renderers, specifically your own functions that you use to render items, you actually had the most control over the UI that you actually rendered for each item. And so you had all the power. However, the trade-off with that is that it wasn't a terribly good toolable solution. So you couldn't use something like Blend for HTML, have a designer like fine-tune and look at the great user experience for just that one tile. And the other side of that is that we provided you binding templates, which was a declarative way, which was great and it was toolable, but there was some overhead associated with those binding templates. And so you as a developer, you had to make that decision of like, well, do I want it to be easily tooled, or do I really want that raw performance and I have to manage building UI in JavaScript, or doing string concatenation with HTML, which can sometimes be a little bit unruly. And so moving on to the next kind of issue that we've faced is that the complexity and the cost of those items can actually have an impact on panning performance. And so if you have a really deep, complex item tree of UI, like you have tons of nested things, or if you have a really wide tree where you have lots and lots of elements, that's going to take some time to actually render that. The HTML platform is going to have to do layout, display, and formatting on all of those items. And so the cheaper the item is, the faster you can render it, and so the better your panning performance is going to be. So if you have really big, complex ones, it's going to impact your performance. And so that's all about kind of the issues that we've seen on your side of that relationship. So let's talk a little bit about the list view. And so like I said, our job is to really manage items and manage when to tell you when to render. And so we had some overhead in managing placement of items, specifically how we lay things out. And so we did some things in JavaScript, and that equated to time that we were spending in JavaScript while you were spending time in JavaScript for rendering items. And so that had some impact on panning. And so I'm going to talk about some of the solutions that we have that we can use today, both on your side of that relationship and our side on that relationship. And so first I'm going to talk about our new optimized binding templates. And these are really cool. I really like binding templates. I think it provides you a good mix of performance, toolability, and in this case we actually optimize them so that they're actually fully debuggable. And so that's really nice. And we'll go through a little demo of that. So we did that to binding templates, and actually we compile them into a rendering function, which is really cool. The dev who worked on this, he used to work on compilers, and so it's really neat. We have a little mini template compiler in Win.js. And so when we step through the code, you can kind of squint at the rendering function that's generated, and it should probably look similar to things that you would have in your own custom renders. And so we'll look at that a little bit later. And also, those binding templates, they participate in the dispose model as well. So with binding templates, you can have data-bound declarative controls inside of them as well. And so if you're using a Win.js control, we're going to participate in that dispose model. And so as we do virtualization of items, and we have those items that are really on the far periphery of the viewport and those buffers, we're going to actually dispose them because we're going to be a good citizen and manage the memory associated with panning. And so that's nice that we have that all built into our declarative templates. And so we really believe that binding templates are going to deliver the best solution for you to ensure that you're going to have the best mixed performance, toolability, and debuggability. But you can go even further. And if you really want to take full control over each aspect of the item rendering experience, we still have the multi-stage async rendering pipeline available to you in Win.js 2.0. So you can still use that. And that's really about having the finite control over each stage of rendering. And so an example of that could be when I first get called to render, I lay down a placeholder, and then I go off and the next stage I put in cheap rendering work, and so that could be like setting text and fields and things like that. And then after that, you can do expensive work like loading images and animating those images in. And so one of the neat things that we have in the asynchronous pipeline is we actually have an image loader, which is it manages what items are on screen, and it manages what images it should try to load that's associated with on screen, so that we're not loading images that are off screen already if the end user is panning really fast. And so that's still available today. And so let's jump into a demo of the optimized binding templates. All right, let me switch here. All right, cool. So this is an SDK sample that we have available. And what this does is that it goes and talks to Bing, and it gets some pictures of Seattle, and then it renders it in a list view. And so and it gives you a full range of what types of templates that you want to use with the list view. And so in this case, we're using those binding templates. And so as I pan this guy, we get pretty good performance with the binding templates, and so that's really great. And so what I'm going to do now is we're going to actually step in to that compiled binding template, and we're actually going to step through that function. So that'll be really cool. And so the way that we do that is there's a property on the binding template itself, and that one's called debug break on render, and that one is set to false by default. And so all you need to do is set this as true. I'll save this. I'll F5. And so now we've broken into the debugger, and now I can go down here and I can set a breakpoint inside of the binding template. So let me go do that. I'll hit F5. And so now we're inside of our item renderer. And so the cool thing about this is that now you can actually have a full debug experience. And so you can look at the data that's associated with this guy here, just to make sure that you're getting the right data context with your binding templates. And as I move down through here, you can start to see that this is kind of similar to maybe what you've written yourself in your own applications. Is we're starting to kind of build up that HTML string for you. And so if I go down through here, perfect. So I should be able to highlight this guy, and you can see the result that we've done through that concatenation. So that's really cool. And so let me go down here. Now you'll notice that there's two comments there. There's control processing, and then there's binding processing. And so in this SDK sample, we don't have any declarative controls inside of our binding templates. But if we did, this is the spot where we'd start setting up, calling WinJS process on that element to start processing those UI elements and then processing the bindings associated with that. So an example could be I'm put in a rating control, and I want to bind a value from my data model to the rating value of that control. And so that's where we set this up. And if we keep going down through here, here's where we mark disposable to make sure that we participate in the dispose model. And so I stepped over this. This is really interesting here. And so I don't know and unfortunately the talk is happening right now, is this is a profiler mark that you can use with the tools to actually measure the performance of your items. And so not only is this really toolable, this is really toolable in that this helps you kind of really understand that spectrum of when should I maybe move over to the more control in the asynchronous multi-stage renderers. And so I'm just going to F5 through all of this, and so we could actually step through each data if we wanted to. And so I'm going to disable that here, and we'll run F5. Great. So there's our application, and I think I have time to step through just the user experience of the multi-stage renderer. And so let me see if I can do that for you really quickly. And so this really wasn't apparent because it actually happened really quickly there. And so what I'm going to do is I'm going to increase the delay here so that our items take kind of a longer time. And so here you should actually see each of those stages. And so these are really, really expensive items. And so as I pan and I get into here, you can kind of see each stage of those item renderers, because you can see here's the placeholder. We're going to load in some text, and then we'll load in those images. And so I recommend looking at this SDK sample because it actually kind of steps through that ramp, and it gives you kind of that full kind of end-to-end view of where to start and where you could go if you need to go there. And so we think that's really cool. Awesome. So let me switch back to the PowerPoint. Cool. So if you haven't figured it out yet, the big call out is use our binding templates, because we've worked really hard on them because we believe that they're going to give you the best mix of performance, tooling, and debugging. And if you want to go that extra mile and have each control over each knob, you can still use the multi-stage async renderers. So we talked about stuff that you can use on your side of that relationship. Let's talk about the stuff that we did on our side in Win.js. And specifically, let's talk about the list view. And so the list view control is a little near and dear to my heart. And so in the list view, we mitigated kind of that overhead associated with managing items, and that we've actually moved the entire layout system to work right on top of the HTML platform's native CSS layout. So we're using Grid and we're using Flexbox. And the benefit of that is that the IE team did actually more performance work in those layouts. And so we can take the performance work that they've done and we can hand that back to you. And so that you now have more time to render your items. And so as we keep moving closer and closer together, Win.js and the HTML platform, we'll be getting faster and faster, and we can keep passing on that savings. And so we think that's really cool. And a side effect of that, using that technology, we actually have a more flexible layout system. And Paul Gusmarino talked about that a little bit, of all of the orientations and permutations that we have available in the list view's layout system. And so we're really proud that we were able to do that. And also, if you notice, this is sort of a theme, is that we're really concerned about coordinating work across our controls. And so we've optimized our virtualization in the list view control, in that we've taken advantage of layering that more complex application policy on top of our scheduler. And so we will actually dynamically prioritize those buffers based on your panning direction. So if you're panning this way, we're going to optimize, or we're going to prioritize rendering items on this side of the buffer, and then we're going to prioritize destroying items on this side of the buffer at a lower priority, because that's really important to go render items on that side. And so we leverage the scheduler for that. And so just by doing a couple of these optimizations, we've actually seen additional performance gains in other scenarios. And so I'm just going to show a graph here. And so this is both across our list layout and our grid layout. And we take performance really seriously on the Win.js team. And so you can see here both the kind of the full initialization scenario. And so when I say full initialization, we do some optimizations where when we start up, we'll try to fill in the viewport really quickly and make that responsive for end users to start panning. But the full kind of initialization is when we start building out all of those, the back buffers there. And so if you look at these graphs here, we're seeing roughly about 30% improvements across both kind of the full initialization scenario, our insert scenario, and our delete scenario. And so when we think about this, we're really concerned about all of the permutations and combinations with the list view, because it's a control that's used a lot. And so we think about, well, is it a list view, or is it a list layout? Is it a group list layout? Is it a group list layout with 100 items, 500 items, 1,000 items? And so we're really diligent in measuring performance and ensuring that we're delivering a component that you can trust and understand that we're doing the best that we can to ensure performance. And so I'm going to show the same video that Paul Gusmarino showed. And so this is a version of mail side by side. On your right side, this is Windows 8 with Win.js 1.0. And on the left side, this is Windows 8.1 with Win.js 2.0, where we just ported it over. And so you can see on the right-hand side, it has some trouble keeping up with the rendering. And on the left-hand side, we're doing just fine. And so this was just porting it over and using our automated scrolling technology to pan really, really, really fast. And so our key call out here is use the list view control, and your app's going to get performance benefits right out of the box. And so we're really excited about that. And so I'm going to save the first thing that you encounter with applications for the last topic. And so now we're going to talk about startup time, and we're going to talk about what startup time means, as well as the end user experience that's associated with startup time, and some of the problems and some of the solutions that we have in each of these sections. So first, let's just have a high-level picture of what startup looks like. And so this is the total time here is from when an end user clicks the tile all the way to when your application is ready to use by the end user. And so let's just step through kind of a few of these boxes and what does that mean. And so as we click the tile, there's going to be some bootstrapping of your process. But then you'll get a navigation, and you'll start loading HTML, CSS, and JavaScript. And this is the same pipeline that you're familiar with if you've written websites and web applications before. So it's that exact same pipeline. The only difference is that you're probably not listening to DOM content loaded. Is that you're going to listen to the Windows Runtime Activate event, and inside of that, you're probably going to do some application initialization logic, and here we'll probably do some processing of the declarative controls that we have in Win.js. And so this all kind of happens underneath the splash screen. And once that's completed, that splash screen will drop, and your application might still be getting some data or filling in some of your UI. You're probably going to populate a list view, because we know the list view is one of the more important controls that most applications rely on. You're going to animate that content in, and then once that's all done and all completed, an end user can start actually panning and using your application. And so that kind of entire time is kind of that time to interactivity. And so I want to kind of make sure that we have that framed in our mind when we're thinking about startup in this specific case. So let's talk about some of the problems that we've encountered as application developers. And so this one seems kind of just straightforward, but sometimes loading and parsing of HTML can be slow. And that can be due to just some of the things that we do as developers unconsciously, because HTML is really flexible, and so you can put all sorts of things in your HTML document, and the way that you structure your HTML document can have some effect on that time in that HTML parsing pipeline. And so there's things that is really easy to do. I know I've done them before in applications, and that can really impact that time. And so when we think about startup, every millisecond counts, because we're doing the best that we can to try to get the end user to the interactive experience as fast as possible. And so, like I said, this has kind of been a theme in this talk, is that it really becomes difficult to identify and coordinate kind of the critical work that you need to do in your application kind of before and after the start screen. And so you could say, oh, well, all of my work is really important. I need to do a ton of stuff before my application is nice and loaded. And that makes it's less complex. I don't need to think about how to break up my work and put it in different buckets and think about it that way. But when we're talking about startup, this is one of those kind of special scenarios where you really need to optimize and customize it right for what makes sense for your application scenario at startup time. And so that can be difficult to do. And so sometimes what we'll do is we're going to have a really short splash screen time, because we're just going to defer a whole ton of work, and we'll put spinners and we'll let stuff kind of float in at different times. And so that experience has some kind of mixed results, because you might have some UI that's relying on other pieces of UI to be loaded, and so you really need to be cognizant that sometimes just deferring more and more work is actually increasing that time to interactivity, even though that the application is on the screen and the end user can kind of poke things and maybe move things here and there. And so let's talk about that, and let's talk about that timeline, and let's overlay some user experience across that to be kind of really concrete. And so let's think about that orange work that we talked about that's underneath the splash screen, and so we're kind of familiar with this. And then sometimes we've seen this pattern where the splash screen will drop really quickly, and then we have a spinner because we're waiting on content. And this almost feels kind of similar to a second splash screen, but at least it's the app. It's not kind of a static thing. And then finally, once we've done all the work to go pull in our data and load our UI, we do a nice animation, and now our application is ready to use. And so we're going to use this scenario as a way to try to identify and optimize some of those areas and find solutions that you can use as a developer for your application during this startup process. Cool. Okay. So one of the first things that we need to do to kind of shrink the overall timeline that we have to interactivity is we need to start optimizing each of these sections. So let's first talk about how do we optimize our loading and parsing of HTML. And so the beauty about this, what I said before, is that this is just the same HTML pipeline that you're familiar with your websites and your web applications. And so all of those tips and tricks that you've been collecting over the years on how to make your apps fast on the web, they still apply to WWA, or to HTML applications today. And so Jason Weber has a really awesome talk that he did in Build 2011, where he actually spends an entire hour stepping through 50 performance tricks that you have just within this one section. And so there's lots of stuff that's out there today, and I'm not going to go over all of that because we would just be here me talking about this one slide. But so one of the nuggets that I'm going to kind of pull out of here, that because I've fallen into this trap, and I talked a little bit about that in the problem is section, is that you really want to ensure that you have well-structured markup. And so I know, and you guys have probably done it too, where you have inline, style tags and inline script tags, and it's like, oh, it's just, it's like a function or something. It's really fine. No. So what happens is during that the pipeline, the HTML is parsing, and so when the HTML parser encounters one of those, either a script tag or a style tag, it's going to context switch, and it's going to go start parsing CSS or parsing JavaScript. And so during startup, like I said, every millisecond counts, and so those context switches can actually add up to it. And so you really need to make sure that you've structured your markup in a way that's optimized for the HTML parser, because you can actually leverage that initial parsing. And so another example is if you really examine your UI and you say to yourself, well, this piece of UI, it's static in nature in that it's always there, and maybe it doesn't make sense for me to dynamically build it during startup. Maybe I should just statically define it because it's a global piece of UI. It really never changes, and so why don't I just do that up front? And so you can do that as well, because you're going to take advantage of that first HTML parse instead of waiting and then processing and deferring it later. And so it all depends on the type of your application, but that's another little nugget that you can take away from that really long talk. And then we can talk a little bit about, because you are an application on the system, that you're a package, and you might have, you might pull down lots of resources. And so you might think to yourself, well, I want to ensure that I have all of the stuff that I need up front, and so I'm just going to include everything. And so loading and some of that stuff does have some costs. We do have some things that help you manage that. And so a great example is, say you're an application that's localized in many languages. And so sometimes it really doesn't make sense to load all of those resources for all of the languages for your application, so you can just make the model for yourself simple. And so you can use things like resource loading and our app resource bundles to manage what stuff that you're going to be loading into the application specific to that locale or to that language. And so after we've kind of talked about optimizing that startup work with some of the tips and tricks that we know and love today, we really want to kind of look at that app spinning splash screen. And so we really want to try and get rid of that. And so we really need to optimize that work that's associated with that. And so once we figure out how to optimize it, what we're going to do is we're going to sneak that underneath the splash screen. And we're actually going to increase the time of the splash screen. Now, I know what you're thinking. You're like, whoa, wait. Like, we want to make the startup time shorter. And we are. We're just extending the splash screen, because what we're doing is we're focusing on reducing the overall time to interactivity, so that once we drop that splash screen, an end user can start interacting with their application. And so I'm going to talk a little bit about what we can do to achieve that. So the scheduler makes its debut once again. And what you need to do as an application, you really need to understand what is the critical work that you need for startup. And so a good example of that is, say you're building your RSS reader app, and maybe you already have some cache data that you've gotten down from the server. And so it might be super critical at startup that you go fetch that cache data and load that into the UI. And then you can defer doing a network request to go look for new data. And this is kind of a similar pattern that you might see in some of our Bing applications. Is where you load it up, it loads up really quickly. You see kind of where you were, and then it'll do a network refresh. And so you can actually control that as in your own applications on how you want that end user experience to happen. But so you really need to identify what that critical work is first. And then once you've looked at that work, you need to schedule that at a high priority. And now I know what you're thinking again. You're like, wait a minute, we need to use high priorities, sparingly and appropriately. Well, this is an appropriate time to use high priorities because, as it happens, we're underneath the splash screen. So we're not showing any UI. So we want to make sure that we do all of that work, and all of that work gets completed underneath the splash screen, and we're ready to go. And so the way that you can do that is you can use a feature on the scheduler called request drain. And so that gives you two things. And so the first thing that it gives you is it will take, at a given priority, it will execute all of the work at that priority and above without doing any time slicing. And once it's completed all of that work, it'll return a promise for you to use however you want. And so in this example here, during startup, we can include that promise in the promise chain that we set during activation, and so that we can really ensure that once we've drained the scheduler at a high priority, so all of our high priority tasks have completed, that splash screen is going to drop and we'll be ready to go. And so I'm just going to show a code example of what that might look like inside of the VS templates, or inside of the context of the VS templates. So let me switch over here. Okay, great. So in this simple example here, I've identified my really high priority work is to sleep, and that's just to kind of simulate work done during startup. And so if we look at this pattern here, we disable some of the animations so that we're not doing any unnecessary animations underneath the splash screen. And then we just, this chain looks pretty similar. We're going to do a process all. We're going to navigate the page. And then here's the call right here to request drain. And so if I go all the way over here, we'll see that we're doing that at above normal +1, so that we're really sure that we're capturing that entire high bucket of work. And then after that, we enable animations, and then we return that in the promise chain to the activate event. So if I run this guy, it should start up, the splash screen should drop, and we're ready to go. And so this looks very similar to probably what we've seen before in the templates. But one thing that I do warn you about this is that, like I said, you need to be real super critical on what you include, because actually if you include too much work, so let's increase this to, we're sitting here and we're waiting and we're waiting and we're waiting and we're waiting. Oh, there we go. Okay, great. So you need to be really cautious about using this pattern, but it's really helpful because once that splash screen drops, your application, it's ready to go, and an end user can start interacting with it right away. And so let me go back to the PowerPoint. So the takeaway for startup is leverage those tips and tricks that you already know, that you've probably already used through your web apps and your websites, and use the scheduler to schedule that startup critical work. And so I'm going to optimize this talk here for you into just one kind of succinct slide. So if you forget everything that I've said, just make sure you go to the summary slide. And so this is going to be the area plus the solution for you to help kind of manage that in your application. So responsive UI, use our scheduler. Awesome. For managing control lifetime and memory, use our dispose pattern. For panning, keep on using binding templates, our list view, and our async renderers, and we're just going to make that even better for you. And then for startup, leverage those performance tricks that you have and use the scheduler and request drain. And so I'm going to put up just some more resources for you. These are some talks. If you didn't get to see WinJS 2.0, that one was really great. Chris Anderson had a talk about the cost of building UI. That one's really great. And so he talks about some of the trade-offs that you need to make from more of a general application and platform selection. But there are some nuggets in there as well. And then, like I said, there's a performance talk that's actually happening right now that talks about just the tooling experience on how you can use tools to measure all these scenarios and to make those evaluations of when you need to use the type of tools that we have available to you. And then also the scenario-guided app performance talk is really great because they kind of take it from another pivot where it's more kind of scenario-based and it's more it's platform neutral. And so they talk a little bit about XAML and they talk about HTML as well. And I recommend going to the mail talk on Friday because they're going to talk about all their experiences with WinJS and how they've done more improvements on the mail application. So I'm going to stick around. I know everyone's kind of itching to go to the after party. So if you have any questions, just come on up and we can chat about them. All right. Thank you.